Hello, this is a video tutorial for image processing made by Robotix IIT Kharagpur. In this tutorial, we will be covering the writing and execution of basic introductory programs using OpenCV. Now, it is assumed for the purpose of this tutorial that the user has already gone through the tutorials for integrating OpenCV with Visual Studio 2010 and therefore has such an installed system on the computer, and also that the user is familiar with the certain programming concepts that shall be needed for image processing and which are explained in the tutorial on important programming concepts. So these assumptions have been made. So now we had studied how to integrate OpenCV. Here we will be studying the basics of manipulating images, which is what we shall be using for image processing, and we'll get acquainted with some useful OpenCV functions. So now let's go straight to the program. The first sample program that we'll discuss will very simply read an image from the file and display it on the screen. So this is something what will look like. The directives at the top are necessary for us to be able to use the functions, the preloaded functions of the OpenCV package properly. HiGUI.h, CV.h, CXCore.h. All of these have been specified before as having the necessity to be included before the program begins. Thereafter we move to the main function. Now as has been explained before in the tutorial on programming concepts, IPL image is a type of structure, the pointers of which refer to images. So here IPL image star img basically declares a pointer to that type. This will refer to the particular image that we are loading from the file. Also, in image processing with OpenCV, we need windows, specific windows to execute certain actions or display certain things. We need to specify them. So here we create one such window with the name image. Then we encounter the first function of OpenCV we shall use in these tutorials, and that's CV load image. It, as the name suggests, is responsible for loading an image from the file into the program. So it has two parameters. The first parameter is the name of the image in double quotes, and the second is a number which is 0 if the image is not colored and 1 if the image is colored. It is important to remember one thing, that the image in question that is being loaded must be present in the directory of the project in Visual Studio 2010, otherwise it will not be loaded properly if we just provide the name of the image. Now if this image pointer, if it is not loaded properly for whatever reason, it returns a null value. So we have kept a condition there that if it returns a null value, then the not of that, which is always true, that shall be executed, and the print statement could not find the image, or could not load the image rather, will be executed. Of course we will, for normalcy's sake, assume that the image will be capable of being loaded from here on out. So in the future functions we shall not be using this if else as such. We will be assuming that the image has been loaded properly. Now in case the image has been loaded properly, this is what will execute. First we need to initialize the window. We give it a particular name, and in this case is the name that we are already decided upon. And the next parameter of the function, CV name window, that is responsible for this, is the flag that refers to the size of the window. The one we use most commonly is CV underscore window underscore auto size, which means that the window will auto size itself based upon the original size of the image that is being shown there. Now finally we have to display the image. This is done using a function called CV show image. The first parameter is the window in which you wish to show the image, and the second is the image pointer itself. Thereafter, after this has been done, we wait for the user's keystroke to continue. So CV wait key 0 has been specified there. Once we exit this if else structure, the image that we use to store or refer to, the image pointer rather, to use to refer to an image, has to be released from memory, and it is done so using the function CV release image. Similarly, the window must be closed. It is done so using the function CV destroy window. So let us have a look at how this works. In our Visual Studio package, this has already been copy pasted, so we'll just run the code again. Build is up to date, and let's have a look and see that this works. It's running fine, and here we see this picture, which was present in the directory of the project for testing purposes, has been loaded carefully, so and correctly, and that's that. So that is basically the first introductory program. It's simple to understand, it's basic stuff, so it should not be a problem. The next sample program will be slightly more complicated, at least in its operations. Instead of loading an image, this program will attempt to generate an image, actually create it and display it. And of course there will be a peculiarity to it. We'll divide it into 3 1/3. The uppermost will be completely blue, the middle one will be green, and the lowermost will be red. Now in and of itself the program might not have any long-term applications, but it is important to understand this program to basically understand how to manipulate and access the data of pixels in an image. So for this program the directives are the same as before, there is no problem there. Same goes for the declaration of IPL image, IMG, and character win. In this case the image does not refer to that returned by a CV load image function, rather we use the CV create image function, which has 3 parameters. The first is the size of the image that we wish to create. It is specified through a format called CV size, which is a function there, followed by first the width in pixels and then the height of the desired image in pixels. So that's that. Then the next parameter is the standard depth in bits of the pixels. In this case it's 8. So the macro IPL underscore depth underscore 8u. At this point it's important to remember what macros are. You can find it in the programming concepts tutorial. IPL underscore depth underscore 8u refers to 8. And finally the last parameter is the number of channels of the image. Since we are talking about a color image, it's 3. Now we had explained previously how the IPL image structure has several member variables and attributes. We will be requiring them for accessing the values of the pixels. Now what does that mean? Basically we want to generate a particular color and a pixel based on its row value, right? If it's in the top 1/3, then blue, and so on and so forth. So we need to be able to access the data of individual pixels of an image. And to understand that, we'll be showing you a particular graphic that will make it slightly easier to understand. We had mentioned before how the image is to be assumed as a 2D array of pixels. However, in memory, truly speaking, there is nothing actually as two-dimensional storage. It's all one-dimensional, it's all linear. One is stored after the other. So if you follow the cursor over here, once we go through here and we go to the last of this column, in memory the next location or the next contiguous location is actually the start of the next row. So that's how it's linearly related. Now we need to be able to access, say, a particular pixel, say a pixel I comma j of the image, and we need to access the values and manipulate the values of the channels of that image. So how do we refer, knowing that we have some particular ij, knowing ij, how do we refer to a particular pixel's channel values in an image like this, which has 3 channels and of course is a two-dimensional array, I mean imaginatively a two-dimensional array. So we need to refer to it linearly. Now how does that go? We use, as has been shown here, we get the value of the height, value of the width, the value of the width step. Width step, if one recalls the previous tutorial, is the distance or the difference in bits, as in memory status, between 2 pixels that are in the same column but on successive rows. For example, this pixel and the next one, in between this there is a gap of width step in bits. And of course nchan is the number of channels of the image, in this case 3. So let's have a look now at the diagram. Say the objective or the idea in mind is to be able to refer to a particular channel of a particular pixel I comma j. Now as we show you the diagram, it will be useful if you can simultaneously refer to the program that we have written and the code that we have written for clearer understanding. Now we know that in this case, if you have a look, let's consider a very trivial image of 5 by 4 pixels, say width 5 or width 6 rather, and height 5, and the pixels are numbered 0 to 5 in the horizontal direction and 0 to 4 in the vertical direction. And also the I in this case is 2 and j in this case is 4. So we want to linearly, the pixels are stored in this manner. First we have 0 comma 0, they're stored row wise. So first we have 0 comma 0, then we have 0 comma 1, then 0 comma 2, and so on and so forth, 0 comma 5, and then we again go to 1 comma 0, 1 comma 1, and so on and so forth. So we need to go to the starting point of pixel I comma j. Now have a look, if you follow the cursor here, you'll find that in covering a row, width step number of bits has to be covered. It's very simple. In fact, anyone who is familiar with the concept of referring to particular elements memory in an array will be very familiar with this. So width step is the number of bits separating one particular row from another in memory. So for every row that is covered, then width step number of bits is advanced or is moved forward. So if I rows have been covered, or rather if we are at the start of the ith row, then knowing that we started from 0, then I such rows of width step bits will have been covered. So have a look here. I comma j is 2 comma 4, I is 2, so here we have one row has been fully covered, so that's width step 1 or once, and again width step twice or 2 times, and I in this case is 2. So I into width step will be one of the additions that need to take place. The second is now based on the column number. What happens is between two elements or two pixels of the same row but successive columns, they are separated only by the number of channels, in this case 3. So if we go from say the 0th column to the first column, there will be a difference of 3. So if we have in a particular row preceded by j columns, then there will be a difference of j into 3 or j into n chan. Let's have a look. So here j is 4. So to go to the starting, we'll need to go first. There's for the first element of this row there's 3, then there's 3 again 1, the 6, then there's 3 again 9, and 3 again 12. To get to the starting point, we have to again advance by j into n channel. So that's that. And now knowing that it's a multi-channel image, we want to refer to specific channels of that image. Now we can add to this expression 0, 1 or 2 based on whether we wish to refer to the 0th channel or the blue channel, the first channel or the green channel, or the second channel, channel number 2, the red channel. Accordingly, if we do that, then we can access these particular channels and the value that these channels are containing. So let's go and have a look. Once this is understood, it's very simple. We cycle through the image pixel by pixel. Then we first go to the starting point of that particular pixel. We give it a name called loc for location, and now we can easily refer to loc plus 1 and loc plus 2 and find out the values of that point refers to, that channel refers to. So first we initialize all of these 3 to 0 so that to prevent any previous garbage value from affecting it. Now if I is less than a third of the height, that means it's in the upper 1/3. So we'll designate the blue channel of that particular pixel and nothing else. We'll designate that 255, making it completely blue, and put nothing else in it. Similarly, if it's greater than 2/3 the height, as in if it's in the lower 1/3, then we want red. So we go to LOC plus 2, loc plus 2, which is the red channel. We give that 255. As you all know, giving it 255 is the maximum intensity or the maximum amount that color is present, and since all others are 0 in this if else if block, and that can be accommodated. Or finally, if that is also not what we are looking for, as in if we want to now focus on the middle rows, then in that case, if I is in between 1/3 and 2/3 of the height, the first channel or channel number, or rather the second channel or channel number 1, the green channel, is now made 255. So it's really as simple as that. In this case, we are using the array which refers to the data of the image. We're using it directly to basically manipulate the values of the pixels and the channels. After exiting the loop, we again initialize the window, show the image, wait for the user's key, release the images, and destroy the windows. So this is again pretty simple. Let's just copy paste and see that this is working properly. If it is working properly, then we'll be provided with an image of 3 divided into 3 such colored blocks. So let's have a look. It has been built properly. Now let's run the program and see what happens. Now you see it. The desired image has been shown. Blue on the top, green in the middle, and red at the bottom. So it's basically as simple as that. Through this, we're able to understand how to access the data of the image, and through the particular pixels and channels, and therefore manipulate them. There is one more important side point that needs to be mentioned. after which it will be very easy. We had mentioned in the previous explanation that certain amount of effort needs to be done to calculate the particular address of a pixel in memory, and for larger applications this will be cumbersome to do again and again. So we use a generalized macro to help achieving this goal very easily. We define it, give it the name img data, which is pretty aptly named because it gives data about the image. And what happens basically is, as a result of this macro, wherever img data followed by the correct parameters, the first parameter being the pointer to the image IPL image variable, the next two parameters being the row number I and the column number j respectively, and k being the channel number 1 of 0, 1 or 2. If this macro is properly referenced to in the code, then simply put the value, the unsigned characteristic value between 0 and 255 will be returned as a result of this macro, which is uchar star image referring to image data, I into image referring to width step, plus j into image referring to n channels, plus k. So here basically the first part, this part is the img dat image dat array that we had discussed in the previous explanation, and all of this is LOC plus 1, LOC plus 2, etc., made very easy to operate and work with. So that's that. For the sake of clarity, we're just showing the second program that we studied again using the macro. Here you see the macro has been defined before the program begins. Inside mostly it is same, except for once you enter the loop we go pixel by pixel. Now using image data we can directly refer without having to calculate LOC, without having to have variables for width step and n channel. We can directly refer to a particular channel of a particular pixel of the picture without worrying, without having any other problems or hassles. So accordingly, if I is in the upper 1/3, the 0th such channel is made 255. Otherwise, if it's in greater than 2/3, the channel number 2 or the third channel is made 255. Otherwise, channel number 1, again the green channel, is made 255. So again, accordingly, as we had seen in the previous example, the working is exactly the same, only we are using this macro, which really makes our life easier. And hereafter in the various image processing modules that follow, we shall be using this macro as well. And so that's that. With that, we come to the end of this tutorial. Thank you.